Turning our attention now to solve few problems on variables and separables from differential equations of first order and first degree. If you really like this video, make it a habit that you practice for some time in a day. So you have to get a mental note if you get a mistake. Pick up that mistake and practice well, and definitely you will conquer your mistakes and you will be successful. So keep watching my videos and it will be very useful. And the most important problems are discussed today. So here from the variables and separables topic, so we have to solve dy by dx plus root over 1 plus y square by 1 plus x square is equal to 0. And the next question here is dy by dx is equal to e power x minus y plus x square into e power minus y. And next third question is 3 e power x tan y dx plus 1 minus e power x into secant square y dy is equal to 0. And the final one here is e power x minus y dx plus e power y minus x dy is equal to 0. First thing is we have to separate the variables. And then we have to integrate on both sides so that we'll be getting our solution. See, for the first question here, in order to separate the solution, so here is the solution. What is given here? So it is given that root over, see, it is given that dy by dx plus, so this is dy by dx plus root over 1 plus y square plus 1 plus x square is equal to 0. So in order to separate the variables, so here dy by dx is equal to, I am sending the other side, the term to other side, that is 1 plus y square plus 1 plus x square. So here dy by dx, so I am separating the root, that is minus 1 plus y square by root 1 plus x square. See, I am sending y terms to one side and x variables to other side. So this will be dy by root 1 plus y square which is equal to, this is minus, if I send dx to other side, this will be dx by 1 plus this value is x square. So if you see, y variables are at one side and x variables are one side. Now integrating on both sides. If you integrate on both sides, see, this will be dy by, so this will be dy by root, this is 1 plus y square is equal to minus dx by root 1 plus x square. So now integrating on both sides, so this is with respect to, so this is also with respect to y and this is also with respect to x. Now here, so what is the formula? Integration of 1 by root over 1 plus y square is nothing but sine h inverse of x. Sine h inverse of y this side, and this is minus a sine h inverse of x plus the constant here I am taking as sine h inverse of c. So the constant can be taken as per our wish. So if I send this sine h inverse of x to other side, so this will be sine h inverse of x plus this is sine h inverse of y is equal to, this is a sine h inverse of c. So this is the final solution for the differential equation. So here this is very easy, dy by dx is equal to root over 1 plus y square by 1 plus x square. So if I send it to other side and if I separated the variables x to one side and y to one side and now integrating on both sides, and this is the final answer, and this is how the variables are separated and integrated and we got a solution. And the next question here is dy by dx is equal to e power, so this is e power x minus y plus x square into e power minus y. So here for this the solution will be, see, here we have to separate the variables here. So in order to separate the variables, what we have to do? So the easy way here is, so first I am writing dy by dx. So this is e power x by, so e power minus y can be written in the denominator as e power plus y plus this is x square by, this is e power minus y can be written as a positive value in the denominator. And now I'll take e power y as an LCM here, dy by dx is equal to, so if I take LCM e power y, then this will be e power x plus x square. Now I have to separate the variables, so y to one side and x to one side. So I am sending e power y into dy and this value, so this is e power x plus x square into this value is dx. And now here after integrating, see here, so now I am going to integrate on both sides. So if I integrate on both sides, see what happens here. So this is integral dy and this is integral dx. So I'll write separately as this is integral e power y dy, and this value is integral e power x dx, plus this is x square dx. Now I am going to integrate. E power y is again e power y, and e power x is again e power x, and x square is nothing but x cube by 3 plus c, and therefore this is the final answer. So I am writing that is e power y is equal to e power x plus this is x cube by 3 plus c, and this is our the solution after variables and separables method. And next, the third question here is, so what is the third question here? Solve the differential equations. 3 into e power x tan x dx is equal to, so here 1 minus e power x into secant square y into dy. Now how to separate this? So in order to separate the variables, so here I am sending, so this is e power x tan y into dx. So I'm sending this plus term to other side so that I can separate easily. That is minus 1 minus e power x into this value is a secant square y into dy. Clear? Now there is an x here, here, x here. I'm sending x to one side. So here there is an x. So this will be 3 into e power x into dx divided by, this is 1 minus e power x. In this side, this is minus, this is a secant square y into dy divided by, I am sending this tan y to this side so that, so all the values are separated. So after separation, see here, this is 3 e power x dx by, this is 1 minus e power x, this is minus, this value is a secant square dy by, the value here is tan y. So now integrate on both sides. So if I integrate on both sides, then see the value of 1 is 0, the derivative of 1 is 0, and e power x is e power x. There is no minus here, and therefore I am writing minus 3 log of, this is 1 minus e power x. And here tan y derivative is the secant square y dy. So here it is okay. Minus this value I am writing as log of, this is tan y plus some log c. Clear? Some log c. So if I send this to other side, then this will be 3 log of 1 minus e power x minus this value is log of, this value is tan y is equal to, so this value is equal to, so this value I am sending log c to any side we can send. So here 3 I am sending it to the as a power, this is log of, this is 1 minus e power x whole cube minus this value is log of, this value is tan y is equal to, this value is log c. So here log a minus log b is nothing but log a by b. Log, this is 1 minus e power x whole cube by this value is b. Log a minus log b is not, log a by b is equal to log c. And therefore, if I cancel log on both sides, 1 minus, so 1 minus e power x whole cube by this tan value is equal to c. And therefore, 1 minus, this value is 1 minus e power x whole cube is equal to c times of this value is tan y. Clear? So this is the solution. After separating the variables and integrating, the final answer is this one for the third question. And the next one is the fourth question here. Solve the differential equations e power x minus y dx plus e power y minus x dy. So here we have to separate the variables. So how I am going to separate the variables? See here, this is e power x minus y dx plus this is e power y minus x dy is equal to 0. In order to separate, see what I have to do. So I am sending this one. So this value I am writing this e power x by, this is e power y into dx, and this value e power y by, this is e power x dy is equal to 0. And now if I send this term to other side, see e power x by e power y dx is equal to minus, this is e power y by e power x into dy. So now I have to separate these. So there is an x term here, I am sending it to other side. That is e power x into e power x dx is equal to minus. So this is minus e power y into, this is e power y into dy. So now this is e power x plus e power x value, here the value is 2x into dx. is equal to minus, this is e power 2y into this value is dy. Now see here, this is e power 2x dx is equal to minus, this is e power 2y into dy. Now I have to integrate on both sides. If I integrate on both sides, see what happens here. So this will be e power 2x by 2. This is minus e power 2y by 2 plus c. And now if I send it inside, then this will be e power 2x by 2 plus e power 2y by 2 is equal to c. And this is e power 2x plus this is e power 2y is equal to c. And therefore, this is the answer after separating the variables and integrating, and this is a final answer. This is how we have to solve. These are all the simple steps. If you follow all the steps one after the other, so you will be getting a crystal clear idea on how to do, what to do, and how to solve, and definitely you will be very successful. And each and every problem from the textbook is solved and posted in the playlist. And go through the playlist of differential equations of first order and first degree and share it with as many friends as you can. And that is the greatest help needed to this channel. And stay connected and practice well. Thank you.